Okay, we're going to continue talking about atomic structure today. We're going to look at groups of the periodic table. To begin, we're going to talk about the general categories. So there are three general categories that we have. First, there are metals, okay, and metals, they are on the left side of the table, left of the step that you see here. We have nonmetals, and the nonmetals are found to the right of the step. Okay, so right side, with one exception, which we'll talk about. And then right along the step, we have elements that act like metals and nonmetals that we refer to as metalloids. And these are along the step. Okay, so that step you see bolded right here. We're going to begin by talking about some of the metals specifically. So where I have the outline in red, that outline indicates that the general category of element is a metal. Specifically, this group is known as the alkali metals. Okay, so our alkali metals found here in group 1A that you see bolded here. Notice hydrogen is not in that grouping. Okay, we're going to talk about hydrogen in just a sec. Something about alkali metals though, they have one valence electron and they are very, very reactive. They're soft, shiny metals, and they will react when thrown into water vigorously. Secondly, we have this group known as the alkaline earth metals. Alkaline earth metals. Now, alkaline earth metals, again, general category of metals. These metals have two valence electrons, so they're still very reactive, but not as reactive as the alkali metals are. Our third group, here in the middle, these are the transition metals. And the transition metals, okay, this is just another grouping containing a lot of elements here within the d orbital group, which we'll talk about a little bit more later. But these are known again as the transition metals. Now, the next group that we have starts here with cerium element 58. These are the elements that follow lanthanum, and these are called the lanthanoids, or the lanthanoid series. Okay, the lanthanoids, they tend to be heavier metals. Some of them are radioactive as well. More of the next series is though. Okay, so this is another metal set below the lanthanoids. After actinium, we have the actinoid series, or the actinoids. Collectively, the lanthanoids and actinoids, these are known as the heavy metals, or more specifically, the inner transition metals. Okay, the inner transition metals. Now, be aware that many of these, they are radioactive. You see some of these average atomic masses in parentheses. Many of these are shown this way because they've only existed for very brief moments in a lab, artificially created. Okay, so you see those in that grouping. They have kind of cool names like americium, berkelium, einsteinium, cool stuff. Now our last metals grouping, these from aluminum down here to bismuth, these are known as the post-transition metals. Okay, so the post-transition metals are again in the category of metals, just another group. Okay, now this is where it gets kind of interesting. So again, the left side are all of our metals, and then along the step we have metalloids. Metalloids, here shown in green, they have properties of both metals and nonmetals. Okay, so let's kind of get into those nonmetals. Now our general nonmetals, carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, and you see hydrogen over here is in that grouping too. Even though hydrogen has one valence electron like the alkali metals, its behaviors are more closely like that of nonmetals than metals. So those are our nonmetals. Many of them tend to be gases at room temperature, whereas the metals tend to be solids at room temperature. Now one specific subset of the nonmetals, this grouping here is known as the halogens. The halogens, shown right here, these are kind of like the anti-alkali metals, okay? They're the opposites. Incredibly reactive as well. And if you get alkali metals along with halogens, they react very quickly, very vigorously together. So one special grouping of nonmetals, group 7A, known as halogens. Now, our last grouping here, again outlined in blue, so you see the blue outlines again are the general category of nonmetal. These are the noble gases. And the noble gases, they have a full electron shell on their outside, which means they're very unreactive. They really don't want to get together with anybody. They don't want to change. They're already pretty much set. So a couple key things to be aware of just in general about the organization. Notice that going from left to right, we referenced this before, but atomic number goes up from left to right. So they're in increasing atomic order from left to right and top to bottom. Notice these numbers along the left side, number 1, 2, 3, 4, 5, 6, and 7. Okay, these are the row numbers, also called the periods of the periodic table, right? Periods go left to right. Besides the periods, one thing to be aware of though is these periods also relate to energy levels, which we're going to get into a little bit later. Okay, so the energy level of the final valence shell. One last thing to be very familiar with is periods go left to right. Up and down, we have groups along the table, or families. Okay, so up and down are groups, left to right are periods. Okay, so group 1A, for example, my alkali metals. Group 2A, the alkaline earth metals. Okay, group 7A, the halogens. That's how that works. Now, I'll give you a second to pause this video, work out the first set of practice problems here. I will assume you've paused it and we can move on. So first off, what kind of element is cobalt? If you look back, cobalt found here in the middle. It's outlined in red, so you know that cobalt is a metal. More specifically, this is one of our transition metals. So cobalt is a transition metal, and again, it is a metal. Next, what kind of element is neon? So we find neon here in the table, and you see that neon, outlined in blue, means it is a nonmetal. Specifically, it is a noble gas. So neon is a nonmetal, specifically a noble gas. Now question 3, what is the last element in period 3? Recall that periods mean rows. Okay, so we want to know the last element in period 3. Last of period 3. So we'll go back here, and period 3, the last element is argon. So last element, argon, Ar. The bottom of group 3A is which element? Now we want to look specifically at groups, so up and down. Group 3A, the very bottom, it's going to be thallium. So group 3A, we have thallium, TH. 5 here, did I say TH? It's TL. Oops, a little flub there. Sorry, that's thorium. TL, thallium. How many electrons does magnesium have for bonding? Okay, so now we're going to talk valence electrons. We mentioned this a little bit before. The valence electrons are equal to the group number. So magnesium is here in group 2A. If it's in group 2A, this one has 2 electrons available for bonding. So magnesium has 2 valence electrons. Question 6, how many electrons does chlorine have for bonding? So chlorine is in group 7A, again 7A, so the A group number is the valence electrons. Chlorine has 7 valence electrons. What element group is calcium found in? So I want to know what is the group calcium is found in, and that is group 2A. Specifically, the element group is the alkaline earth metals. Okay, so calcium is an alkaline earth metal found specifically that is in group 2A. Okay,